All right, so the video 1 covered the basic definitions. Video 2, what we're going to do is we're going to actually do some homework problems. All right, so again, one of the ways to start this is you need to include all this information right here for each of these graphs in 6 to 12. And again, they continue on the next page. So go ahead and just write them down to start off when you're doing the homework problems, and then you'll just fill in the blanks from there. All right, so we're going to be looking at this problem right here. And a big warning for the book too on these ones is the book doesn't like arrows for some reason. This graph does continue on forever. This graph does go down forever. And we're looking at number 6 right here. So even though it looks like it ends, it doesn't. All right, so for all these on the book, just imagine they go on forever unless it's something like 11 where it ends at a point. Okay, and I think 11 is really the only one that I see it doing that. So everything else, just imagine it goes off to infinity. All right, so first thing on our definition is where is this function increasing and where is it decreasing? So remember, we go left to right. So we're going uphill, 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 uphill. We flatten out, and then it's downhill for the rest. It's uphill until this point, whatever that might be. Then it's downhill for all the rest. And we're going to answer in interval notation. So the furthest to the left, it can go, going to be negative infinity. Remember, that's always a parentheses. Now the furthest to the right that it's increasing, going to be, well, it stops increasing around there. What x value would you say that is? And you can just guess for all of these. I'd say maybe it's -0.5. All right. So let's just say -0.5. So this is the interval where it's increasing. Sometimes you'll have multiple intervals where it's increasing, in which case you'll connect them with a union and then do another interval. All right. And it's not increasing at -0.5. So we leave this as a parentheses. All right. Because the -0.5 is not included. All right. Now for, whoa, what just happened? Oh, it moves my cursor. I see. Next, we need to figure out where it's decreasing. Well, starting right here, it starts decreasing. Then it's decreasing, decreasing. All right, it decreases forever. So starting at -0.5 and then going on forever, it's decreasing. We'll start it at -0.5 and then it's decreasing all the way to the right of -0.5. You may have to refresh your interval notation here. Next is relative maxes and relative mins. Relative max is going to be the top of a hill. Relative min is going to be a bottom of a valley. So there's a hill right here. We'll find this point. This point will be our relative maximum. But there's no relative minimum. It kind of looks like there might be one over here. But I think it's supposed to be an asymptote. I think it's just flattening out. But again, if it's ever not clear, you can always ask or just make your best guess. So what point for that relative minimum? Again, the x value is maybe -0.5 and the y value is 2, 3, 4, 5. So maybe the point -0.5, 5 right here. So this is a little confusing, right? Because look over here. These right here are intervals. But we're writing these intervals the same way that we're writing this point. So just be a little careful that some of these are intervals and some of these are points, even though we write them the same way. All right, and again, we said there were no relative minimums. And I'm showing you something that you cannot see because you are seeing the textbook. I clicked the wrong thing. You could see the chat though, from where I'm recording this video. So again, these first two are intervals and this last one is a point. So be very careful for that. Again, there are no relative minimums. So next we need to look over and say, okay, what is the biggest that this thing ever gets? And what's the smallest it ever gets? The biggest value it ever gets is the value of the function. It gets up to 5 here. But there's no smallest value because this gets as small as it wants. This is going down to infinity. There's no minimum value because it can keep on getting smaller and smaller. The biggest the function ever gets is when the function value gets to 5. All right. So the absolute maximum looks like it's 5. Absolute minimum is none because it goes off to infinity, negative infinity. All right. Next up, we have to look at concavity. Where is this concave up? Where is it concave down? So it gives you a little hint here that something's happening at this point. Does it kind of look like a downwards parabola or an upwards parabola? Looks like a downwards parabola over here. And then over here, it's kind of hard to tell, but it's curving this way. So it's kind of more like an upwards parabola right here. And this is where it looks like it's switching at this point right here, 3, 3. So when x is less than 3 over here, it's concave down. When x is bigger than 3 over here, it's concave up. So concave down when x is less than 3. How do we write that in interval notation? Negative infinity up to 3. We said it's concave down when x is bigger than 3, so that's going to be the interval from 3 to infinity. And the point of inflection, that's the point where it switches, which we said was the point 3, 3. And again, right, these right here are intervals. This is interval notation. This right here is a point. So be very careful, even though we use the same kind of notation for both of them. Now we just need to find our intercepts. So it crosses the y-axis around here. So this is our y-intercept, is about 5. Crosses the x-axis here. And it doesn't look like it ever is going to cross it over here. We'll have one x-intercept and one y-intercept. The y-intercept looks like it's about at 5, and the x-intercept is like maybe maybe negative 3.5. But again, you're just going to be estimating for these ones, all right? X-intercept is maybe negative 3.5. Oh, not green. The y-intercept is about 5. Again, usually it's good practice to answer your intercepts as points. The x-intercept is when y is equal to 0. The y-intercept is when x is equal to 0. Or you could just say the y-intercept is 5. That works too. All right, last two things. Where is this function undefined and what are its asymptotes? There's no open circles. There's no shooting off to infinity. It's defined everywhere. Defined everywhere. Nice. But there is a horizontal asymptote over here. It looks like it gets really close to the x-axis, but it never touches it. So we do have a horizontal asymptote right here. This is the line y equals 0. This is the x-axis. We'll fill that in, all right? So undefined, well, not applicable. It's defined everywhere. We have a horizontal asymptote at y equals 0. All right, and that's kind of how to approach these problems are over here, okay? We'll talk about one more problem. I'm not going to write it all down, but I do want to talk about a little bit more. If you look at number 12, if we look at number 12, the same chunk right here, that is this parabola right here. So increasing. We're going uphill here, and then we're going downhill, and then we're going uphill again, and then we're going downhill again. So there's a lot of different intervals. So if we're increasing on here, you do have to split it up into sections. So you'd say like it's increasing from negative infinity up to when x is like negative 1.5. And then it's also increasing again once x is 2. And from 2, it's increasing up till about here, which is maybe like 5.5. So for an example, for this one, you'd have it increasing in 2 different intervals. Your increasing would look kind of like this. Make sure to use that union sign in the middle, which looks like just a big U. Right, and then it'd be decreasing on the other half, right? So from when x is this to x being this, when x is this, off to infinity. And again, we have a relative maximum here and here, 2 relative maximum points, and a relative minimum. We have an absolute maximum value of whatever this value is, which is like 3. But there's no absolute minimum value because this goes off to infinity, negative infinity. For concavity, you just figure out where it kind of looks like downwards parabola and upwards parabola. So again, over here, looks like a downwards parabola up until when x is 0. This point right here is our point of inflection. And then we're kind of like an upwards parabola. So from x being 0 to x equal 4, we're concave up. And again, once x hits 4, we're now concave down again. So these are the 2 points of inflection. It's where it changes concavity. Trying to remember my list without checking. I'm going to check. So all that's left is the intercepts, undefined, and asymptotes. So the intercepts, y-intercept here, x-intercept here, 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 and here. There are 4 x-intercepts here. And it's not undefined anywhere. It's defined everywhere. So there are no undefined points again. And then finally, there are no asymptotes. This is just a quartic polynomial. So if you have questions on these, don't have too much time in the video to do more, but if you have questions on these, feel free to ask. And then you have the example problem I did, number 6, all right, which kind of has a little bit of everything. Good luck and let me know.